Okay, hello guys. Today we're going to go over where we left off on Thursday, which was the last part of 3.3.2, which was we went over the the three different types of variation. We talked about range, which you subtract high minus low. And then we talked about standard deviation, which measures the distances from each data value from the mean to see if there were consistency among the data or not. And so there's one more, and that's variance. So what is variance? So variance is pretty much the standard deviation squared. That's basically what it is. A lot of people don't use standard variance much because it's just a huge number. So they really don't use that number for anything except for studies, just to make their study look interesting. They have a huge number, but other than that, no one really uses variance. So symbols we use S squared. S squared is the sample variance. The curly O squared, second power, that's squared, is the population variance. So you see these symbols as the sample variance, sigma squared is population variance. Okay. All right, so then now we've covered all 7 characteristics of statistics. So how do we compute all of them? Okay, so I'm going to show you how to compute all 6 of our statistics. So what were they? They were the mean, the median, the mode, the mid-range, the range, standard deviation, and variance. So those are the 7 things that we're going to find. We're going to compute those. So what makes life easy is going to be using StatDisk. So we use StatDisk. So how do we use it? So when you open up StatDisk, you're going to enter all the data in StatDisk as a column. You're going to put it in column 1, or you're going to preload the data from the data sets. Okay, so we'll show you how to do that now. So just to let you know, so when you, just FYI, when you do section 3.1, right, section 3.1, you're going to find those first 4 items. You're going to find the mean, the median, the mode, and the mid-range. That's for section 3.1. Okay. When you do section 3.2, you're going to find the bottom one. So you're going to find the range, standard deviation, and the variance. So if you want to save paper and time, you can go ahead and find all 7 values when you do 3.1. So when you look at the problems in 3.1 and you compare it with the sections of 3.2, you will see that the columns from 5 to 27 are almost the same. It's only the instructions that are going to be different. They're going to ask you specifically. So I'll show you what I'm talking about. So the hard part isn't going to be the computing part. That's going to be easy, which I'm going to show you now. So I'm going to open up StatDisk. I'm going to open it up. StatDisk. Okay. And let's pick a problem. We're going to do on page 92, we'll do number 5. Okay. So now remember, this is section on page 92 is section 3.1. So look at the instructions. Okay. It says, find the mean, median, mode, mid-range. Okay. So you got to find those 4, right? if you go to page 102, look at what they say on page 102. This 102 is in three. Sorry, I was off by a few pages. Jeez. There you go. Look, there's 3-2. Sorry, it was page 107. Look at column 107. You see, they're going to be they're exactly the same problems, but this time it's asking you find the range, variance, standard deviation. So my advice: do problems 5 through 27 or 5 through 19. Find all 7 things from 3-1, and then you won't have to do the 5 through 19 on 3-2. You can just start with 21. Make sense? Okay, so we'll do number 5. Okay, we'll find all 7 things. All right, so I'm going to go ahead and enter those. We're going to do number 5. Right, I found my pen. Let me find my pen. Okay, so here's number 5. It don't matter if it's page 92 or 107 or 107. It doesn't matter. We're going to find all 7 things. Okay, so I'm going to go ahead and enter those numbers into StatDisk. Okay, and I'm going to put it in column 1. So here I go. 89, 91. 55, 7, 20, 99, 25, 81, 19, 82, 82, and 60. There should be 11 numbers. 2, 4, 6, 8. And you don't have to put them in order. That's fine. Well, you may need to put them in order, but I'll tell you why in a little bit. Okay, so I entered all my data in column 1. Then I am going to go to Data Tools. Just click on Data Tools and scroll down to Explore Data. So Data Tools, Explore Data. Okay. Then it's going to ask you, which column do you want us to do the analysis? You're going to choose number 1. And then you evaluate. And voila! Notice that StatDisk gives you pretty much all of our answers. Look, it gives you the mean, the median, the mid-range, the variance, standard deviation. Okay, so let's look at the problem. I think I typed in the data already. Let me see. I'm having trouble. Okay, so here's our values, right? So pretty much gives you everything. So the hard part is the rounding. So I got to go through the rounding procedure. Okay, so remember I told you not to use the word significant figures. So we in stats have rounding rules that we have to follow. Okay, so let me tell you the rounding rules. Okay, so let me share my screen. Yeah, and you can use StatDisk in a test too, so just letting you know. Okay, so here's how the rounding rules work. So it's all dependent on how the numbers are given. So if your data are given, it is dependent on how I don't know how to spell how data are given. Okay, so if they are given as whole numbers, okay, you have to round all your answers to the 10th. It's always one place further back than how they are given. There's one digit. The answer should be always should have one digit more than how the data are given. So if they're given in whole numbers, tenths, they got to be in tenths. If they data are given in tenths, then you have to round to the hundredths, 2 places behind the decimal. If they're given in 2 hundredths, 2 places behind the decimal, you have to round to 3. It's always one place further back than these. I don't think you have to go beyond thousands, but in case you do, they would go to 10,000. Right. So that's how the rounding rules work for stats. All right, so here's our example. So our numbers, what were our numbers? This is number 5, right? So our numbers were 89, 91, 55, 7, 20, 99, 25, 81, 19. Am I going to have in the space 82 and 60? Right? Notice all of these are what? They are all whole numbers. Right? So I'm going to go to my chart. They're whole numbers, which means I have to round them to the 10th. So I'm going to go and write down my mean, median, mode, mid-range, range, standard deviation, variance. I'm going to go back to stat disk, and I got to round all of them to the 10th. They all have to be rounded to the 10th. All of them. 10th. Okay. All right. Let's go back to my stat disk. Right. So I have to have one place behind the decimal, which means my answer to this one is 57.1. Okay. Median, 60.0. All my answers should have one digit behind the decimal, 60.0. Now, the thing with StatDisk, it does not give you the mode. We're going to have to figure out the mode by ourselves. Okay, that's how it works. You have to do it by hand mode. But all the other 6, you can find it here. Okay, so mid-range. What is our mid-range? I have to have one digit behind the decimal, 53.0. Range, 92.0. Standard deviation, 33.9. Variance, 1,149.5. Okay, now let's go back to my stat disk. Where is it at? Oh, yeah, way up. Sorry, share my screen. So I can show you what I have. Right. So notice these are all whole numbers. all my answers have to be one. That has to have one digit behind the decimal. So 1 digit behind all of my answers. Even though there's a 0, you have to have 1 digit behind because they are whole numbers to begin with. Answer should be tens. All right, mode. We got to find mode. All right, go back to your original data set. Let me go back. I got stuck. Come on, open up. It's stinking. It's stinking. Oh, come on. Come on. Come on. I don't know why. Okay, there it is. Okay, so look at my numbers. I'm going to put them in order. So you remember? Click on the 1, right click, sort from A to Z. Okay, now remember what mode was. Mode was a number that appeared more often than the others. I don't think this one has a mode. They're all different. So I'm going to put no mode. Bam. And we're done. So those are my answers. Okay, so use this chart. Just look at your data and see what it follows. Now, what if you had a couple of numbers that had decimals and then they had whole numbers? You go by the majority. So if you have more numbers that have whole numbers than decimals, then you go with the whole numbers. If you have more numbers with decimals, then you go with that type of number. It's all dependent on which number has the more type of that particular decimal value or decimal place value. Okay, that makes sense? Okay, let's do another one so you can see how it works. Okay, so let's do one that has decimals behind it. I don't see any. There's one. Number 12, cell phone radiation. Okay, so let's do that one. So let me write down the numbers. I know number 12 is not part of your homework, but let's just do it just for the heck of it. 1.18, 1.41, 1.49, 1.04, 1.45, 0.74, 0.89, 1.42, 1.45, 0.51, and 1.38. 2, 4, 6, 8, 10, 11. There should 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, cool. Right. So let me share my screen, show you what I have. Okay. So here are my numbers. All right. These all have 2 decimal places behind the decimal. You don't need to know the name of the place value. You just count. How many numbers do I have behind my decimal? I have 2, right? So I have to have one more than how these have. So there's 2. My answers have to have 3. If these had 3 digits, my answers, all these 7 characteristics, have to have 4. It's always one more. All right. So these are all in hundreds. So when I find my mean, median, mode, mid-range, range, standard deviation, variance, they have to be in thousands or 3 behind the decimal. 3 behind. This one has 2. I can underline it up. They have 2. My answer has to have 3. All right, here we go. I'm going to type them in. Let's go to stat disk. Enter it in my stat disk. Clear. Okay, here we go. I'm going to type them in. 1.18. Make sure you type in the numbers right. 141, 1.49, 104, 1.04, 1.45, 0.74, 0.89, 1.42, 1.45, 0.81, 1.38. 11 numbers. Okay. Click on Data Tools. Explore Data. And select column 1. Booyah. Okay. So remember, I got to go through all my 6 items that are given, and we'll have to do mode later. That's last. But I got to round these two. I have to have 3 digits behind the decimal because my numbers given had 2. I need 3. So mean is 1.178. Okay, 3. Median 1.30. 380. We'll come back and do mode in a little bit. Mid-range is 1.000. Consistency, people. Consistency. Range. What is range? Range is 0.980. There's the range. Standard deviation 0.337. And the variance is 0.114. Yeah, I got to change that 3 to a 4 because next to the 3 is a number higher than 5. So I have to increase that 3 to a 4. Right. And now let's go back and look at my, what was the number that appeared the most? Oh yeah, it's 145, I think. I think it's 145. Let me see. Let's go back to my data. Let's go back. I put them in order. Right click here. Sort. Let's see what number appears the most. So far they look. 145. See, 145 appeared twice. So my mode is 1.450. I gotta put a 0. Okay, so notice 2 digits, 3 digits, 2, 3. They all have 3 digits behind the decimal because they started out with 2. Okay, this side has to have 1 more than the original. Okay, that's how it works. That's how the rounding rules work. Okay, right. So that's how you work them. Again, you're gonna get to use that disk on your test. Just remember your rounding rules. Keep that paper that I just showed you, your rounding rules handy. You gotta have that handy when you round or memorize it. Okay. All right. Cool. So we got that. Okay. So the next thing we're gonna learn is how do you find the mean from a frequency table? Okay. How do you find a mean from a frequency table? All right, so let's look at the problem in your book. This one is on page. Let me see. We'll go back to page 92. I keep getting the Zoom thing. I think it's problem number 29. Yeah, 29 and 31. You got to do two of them. Okay, so let's do 29. All right, so when you write the table, I want you to leave a little space next to the table because you're going to add on to the table. Okay, so let me write down the table. I'm going to do 29, page 95. Page 95, number 29. Okay, so you have the age. This looks familiar, right? We did the frequency table for it. 20, 29, 30, 39, 40, 49. 70, 79, 80. Okay, I got my ages, I got my intervals. I'm gonna put my frequencies. 29, 34, 14, 3, 5, 1, 1. I'll share my screen, show you what I wrote. Okay, here's my table. Okay, and I want to find the mean. Okay, so we can't find the mean like we did with the numbers. You know how we add them up? I know you're thinking, well, let's add these up and then divide by 1, 2, 3, 4, 5, 7, right? No, that doesn't work like that. You can't do it the same way like you do with data given. This is a table. These are counts. This is saying there are 29 numbers of values that are between 20 to 29. I don't know what those numbers are. They can all be 20s. They can all be 21s. They could be a mixture. I don't know what those 29 numbers are. They're just tallies. They're just numbers that are between. So we have to do it another way. All right. So I'm going to give you guys the formula for it. Here it is. It's going to look like Greek mythology, but it's not. Well, it's got Greek letters. Okay, have y'all seen this formula before? You should have covered this in elementary school after you covered the letter Z. If you didn't, that means you went to public school probably. Okay, so this is the formula you're gonna use. Okay, so do you recall what this sideways M was? Remember this sigma, this is a capital sigma. This symbol means the sum of, okay? The top part is difficult. Let's do the bottom part. So the bottom part is saying find the sum of the frequencies. That's what the bottom is. So that's easy. All you have to do is just add this whole entire column. If I add up the numbers, 29, 34, 14, 3, 5. All right, let's plug it into our calculator. There you go, 87. 87. You don't believe me? It's true, it is 87. That was easy. Okay, now the top part. Okay, so you guys remember order of operation, right? You remember in school, order of operations, please excuse my dear Aunt Sally, right? They always told you to do the parentheses, right? So I got to do the parentheses part. So I have to do this thing. So what does that little dot mean? That little dot means times, okay? So I know what my F is. F is a frequency But the x, I don't know what x is. So let me tell you what x is. X is the class midpoints. That's what x is. Okay? So I'm going to label this column to be F. That's what that is. F is this column, frequencies. Okay? Now I have to add another column, and we're going to call this class midpoints. And I'm going to label that as X, right? So you remember how to find the midpoints? I have to get these two numbers, add them, and divide by 2. And I got to do it the same with this one and this one and this one. I got to add them and divide by 2. So I'm going to add 20 plus 29 divided by 2. 30 plus 39 divided by 2. Always divided by 2. Divide by 2. 70 plus 79 divided by 2. 80 plus 89 divided by 2. All right, so let's compute them. Add them, divide by 2. All right, so first one is 24.5. Okay, next one. 34.5. Next one. 44.5. Why did I put parentheses? Why do I put parentheses? Parentheses, just a habit. 44.5, 54.5, 64.5, 74.5, 84.5. Bam! There are all your class midpoints. So I did the X. So I got the X, I got the F. What does my parentheses tell me to do? I'm going to multiply these two numbers. Multiply. So I'm going to multiply. I'm going to circle them. This one times this. F times X. So I'm going to multiply 29 times 24.5. 34 times, I'm going to circle it so lose track. 14 times 44.5. 3 times 54.5. 5 times 64.5. 1 times 74.5. And 1 times 4.5. So I have to calculate those in my calculator. I'll do the last two without the calculator. Is that right? I don't want to show off, but I want to show off. It's a gift, I know. 84.5. I got to multiply the other ones. I got to use the calculator for sure. I'm going to go backwards. I'm going to go down, up. 5 times 64.5. Remember to turn on your calculator when you start typing. 322.5. Next one. 3 times 54.5, 163. 14 times 44.5, 623. 34. 1173. 710.5. Right. So we did F times X, and now I can do the outer part, which is the symbol. This symbol meant what? Sum. So I'm going to add that whole entire column, and that number is going to go right on top of the 87. So let's add them up. 710.5 plus 1173 plus 623 2.5 74.5 plus 84.5 3151.5. That should be the sum. Add them up. If you didn't, then there's something wrong, not with you, but with the calculator, right? Yeah, always bring that in the calculator. That's what I do. So that number goes on top of the 87. And now you're going to divide. So divide 3151.5 divided by 87. And you get 36.2241379.3. So where do you round this number? Hint, hint. Where do you round? Anyone? 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 You round to the tenths. Why? Why do we round to the tenths? Because you see how our intervals are given in whole numbers? I have to have one digit. So my answer is 36.2. This is my mean. Okay. So I'm going to leave it up to you. You guys can do the other one. You can do number 31, and that's the last one for the homework. This is 29. I believe. That is the last one in your homework for 3-1. Okay. Excellent. Okay, so try the other problem, the 31, and then let me know if you still have issues for the next time that we meet. Okay. All right. So we're gonna move on to 3-2. We did the measures of variation in 3-2. I'm gonna go back to 3-2. And we're going to cover a topic called range rule of thumb. It's on page 100. Okay, so let me show you. On page 100, we're going to cover range rule of thumb. Page 10. Page, the grade you guys are going to make in your test. Oh, by the way, about the test, we're going to have to postpone it until February 23rd. So I know you're disappointed, but oh well. Too bad. Okay. There you go. Range rule. What a terrible name. Range rule of thumb. I don't know if you guys have ever had taken history, but they need to change that title of range rule of thumb. That range rule of thumb is back in the medieval times. Men were allowed to hit the women with a stick, and the requirement was it had to be a thumb-inch stick. Terrible. So now women can hit their men with whatever they want, gun, whatever, doesn't matter. But yeah, it's their rule. They need to change the name. Okay, so rule of thumb, page 100. Okay, so let me show you how this rule works. So if you have kids, okay, you have children, when they're born, you have to wait a couple of weeks, and then you have to take them back to the pediatrician so they can do some measurements. And so one of the things that they're concerned about is the weight and the head circumference. Now the weight is becoming an issue because you millennials eat a whole bunch of Takis and hot Cheetos and all sorts of stuff. That's not bueno at all. No bueno. So that's not the, yeah, some of these kids are coming out with mustaches and beards by the time they're born. They're all, you'll get old. They have these huge voice. Terrible. Stay away from the genetically modified milk. Yeah, they're gonna have deep voices. Anyways, so you take your child to the pediatrician and they're gonna show them this chart. It looks like this. You have, it goes like this, without the sound effects, of course. I don't know if you've ever seen something like that, but that's what, if you have kids, they show you this chart. And this is measuring, the most important one is the head circumference, because if the skull is not developing correctly, they could have brain development issues as they get older. So you don't want the skull to be, the cranium to be too big, because there could be liquid forming in the brain, and that's not good. Or if the brain, the skull is too small, then they're going to have issues with the brain growing in such a small skull. So that's not bad. That's bad. So these are the maximum, and that's the minimum. So we call this max usual, and this is called the minimum usual, right? So anything that falls in between here. So if your child falls in this spectrum or this area here, they're good. It is considered usual. So there's no problems. Usual is good. But if they fall below or above the max, that's considered unusual. Bad. Concern. Okay, guys, let's see. Let me show you my picture again. So you have your, let's see, you got your unusual. If it goes above, in between's usual. Anything below minimum is unusual. Oh, what did I do? I was supposed to put Lumpy Space Princess symbol in it. Okay, cool. Okay, let me give you the formula for it. There's a formula. The max usual is mean plus 2 times the standard deviation. The minimum usual is mean minus 2 times the standard deviation. That's the formula. Okay, so we'll do an example. Let's suppose that you are in charge of IQ scores of politicians, and the mean is 100 score. Standard deviation is 15. What is the max usual and min usual? Okay, well, let's write down our formula. Mean plus 2 times standard deviation. Mean minus 2 times standard deviation. And we just plug them in. So what was my mean? My mean is 100, right? Plus 2 times your standard deviation, 15. Plug it in. 100 plus 30 equals 130. Do the other one, same thing. 100 minus 2 times standard deviation is 15. So you get 100 minus 30, 70. Right. So your minimum is 70, your max is 130. So let's say another politician comes in and their IQ score was 50. Where would they be at if they had 50? They would be considered unusual because it's below 70. What if their IQ was 145? 145 goes above 130, so 145 would be considered unusual. What if you had a person who had an IQ of 125? Well, 125 falls directly in between 130 and 70, so that would be considered usual, common. That's how it goes. Okay. All right, so there's your minimum usual, max usual. And now we're going to go through another rule, and this one's called the empirical rule. It is specifically for data that is bell-shaped, okay? So it's called the empirical this rule only applies to data that is only bell-shaped. Okay. So the way things work when things are bell-shaped is that things are symmetrical. Right? So let me draw my picture of my bell shape. Okay. In the middle, we're going to label this as X bar. Do you remember what X bar is? X bar is the mean. Okay. So the mean is in the middle. And then because it's symmetrical, we say that the distance from the mean to the left to the right is equivalent to 1 standard deviation from the mean. So what we do is it's symmetrical. So we subtract standard deviation, we add a standard deviation. We say that the distance from to the left and to the right of the mean, 1 standard deviation. Why did I put a 3? It's supposed to be an S. S is 1 standard deviation from the mean. And then we move on. If we say that this is X bar plus 2S, over here, it's X bar minus 2S. S, that's not a 5, but an S. So we say that the distance from negative 2S and plus 2S from the mean is 2 standard deviations from the mean. And then we do, if we do this is plus 3S, then over here it has to be minus 3S. So what do we say the distance is from the mean? It is 3 standard deviations from the mean. Right. And then we put percentages. So if you were to graph the data that's bell-shaped, they say that the amount of data that falls in between this one standard deviation business, about 68% of the data would fall within that area. If you spread it out more, the percentage gets bigger. So if you plot all the data, in addition to the 68, all the numbers that fall in between the two, it accumulates. They say that this is 95% of the data would fall in between that. If you go even further out, you capture this, and then from here, they say it is 99.7% of the data would fall in between there. Right, so you have to remember these 3 percentages for empirical rule because those are set. 99.7 for the further out coverage, inside 95, and then in the middle. It's kind of like Goldilocks, right? Too hot. This is too cold. Oh, sorry, this is too cold. This is too hot. This is just right within the two. Right, so you got to memorize these 3 percentages: 68, 95, 99.7. 68, 95, 99.7. 68 is 1 standard deviation from the mean. 95 is 2 standard deviations from the mean. And, I can't do it with my hands there. I can't spread out. 3 standard deviations for the mean is 99.7. Okay, so you got to remember those. Okay, so let me show you how it works. You don't necessarily have to memorize these bottom. I'm going to show you how to get these. These are easy to do. You just have to remember these 3 percentages and these tick marks. Okay. All right. So let's do problem in your book. We will do. There's a baby crying. The little baby's crying. I've been crying all night. I feel bad for the baby. I hope he's all right. I hope he's not badly hurt. Okay, so let's do on 3.3. I don't know what page that's on. It is on page 41. That's right, 111, page number 41. 111, number 41. This one. All right. So let's read it together. So it says, use the empirical rule. It says, use the empirical rule. Based on data set 1, body data in Appendix B, blood platelet counts of women have a bell-shaped distribution with a mean of 255.1. So I'm going to write it down. Mean is 255.1 and a standard deviation of 65.4. Using the empirical rule, what's the approximate percentage of women with platelet counts? With A, within 2 standard deviations of the mean, and between 189.7 and 320.5. Okay, so here's what you do. Okay, so you're going to draw your beautiful artistic bell-shaped curve, just like mine, please. Don't be hating mine. Mine's beautiful. Oh, that's nice. That looks exactly like the pimple I developed while eating at Fred's Fish Fry. All right. So in the middle, what do you put? Okay. You put the mean. So my mean is 255.1. Okay. And I'm going to put my tick marks. 1, 2, 3. 1, 2, 3. And to figure what these are, as you go right, you add a standard deviation to that number. you add 65.4 to that number, and then whatever answer you get, you add another 65.4, and then another 65.4. So you continue to add 65.4 as you go that way. You add 65.4. All right, so let's add it up. So what is 255.1 plus 65.4? You get 320.5. Okay, add another one. Add another 65.4 to that number. You okay, Jacob? And then add another 65.4. Okay, cool. So we got those numbers. And as you go, and if you go left, you subtract 65.4 as you go left. Right? Think of the number line. You're going negative, so you continue to subtract. Here, you're going on the positive side. The other one, you're doing negative. So we're going to subtract. We're going to subtract when you go this way. You subtract 65.4. All right, so let's do it. 255.1. 255.1 minus 64.5, and that's going to give me my first tick mark on the left. 189.7. Okay, add another, subtract another 65.4 to this number. 24.3. Add it, subtract another one. 58.9. Okay, and now we're gonna put our little percentages. Remember what was the first percentage? The first inner one was how much? 68%, right? The middle one was how much? I didn't draw it to scale. 95%. And what was the last one? 99.7%. And we're done. Now we can answer the questions. So letter A, what did letter A say? It said, what was the percentage? What is the percentage of women with platelet? How do you spell platelet? Platelet counts within 124.3 and 385.9. Right, so you look at your chart, find those two numbers, and then find me the percentage. Oh, here it is, look. Where do these fall? They fall in which box? The 95. Bam! Easy, done. Okay, B, same thing. What is the percentage of women with plate counts? I'm lazy. Between 189.7 and 320.5. All right, find it. Where is it at? There it is. Where does it belong? It belongs in the inner box, 68%. Booyah. Simple. Done. And you're done. The end. So that's if it's empirical. You have to draw this picture. They got to keep these percentages. Put your mean in the middle. It'll tell you the mean. Then you continue to add the standard deviation. They'll give you that too. As you go right, subtract. As you go left, spot the numbers. Put your percentages. Simple. Da 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 da. Da 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 da. That's empirical. So what is the drawback to the empirical rule? Well, it doesn't actually fit every type of data. We're missing a type of data. What type of data is the empirical missing? Well, it doesn't cover skewed data. Empirical rule is flawed. How do you spell flawed? Because it does not cover skewed data. Right. So this famous statistician, his name was Chebyshev. I don't know his first name. We'll call him Beto. Chevy. He wasn't Chevy either. I think he's Russian. That or Hispanic, I'm not too sure. Chebyshev's theorem covers data that is either bell-shaped or skewed, right? So he kind of almost developed it kind of like this. It's almost like that. So let me show you his. So he designed it almost like this, almost, but he tweaked it a little bit. So let me show you what Chebyshev's graph looks like. So he still put the mean here. That's cool. But he skips the first standard deviation. You know how we did the first standard deviation? We did x bar minus x, x bar plus x. Well, he doesn't believe in it. He said, I can't do a Russian accent. You know to what? I can't do it. I can't do the Russian accent. I can't do it. I do not believe in that. I eliminate. I can't do it. But so he starts with 2, and then he does the 3 minus. Of course, it's symmetrical, right? So he doesn't cover those 2. He doesn't believe those exist. Right. So there's Chebyshev's. And not only that, but the percentages are going to be off. He says that whether it's bell-shaped or skewed, 75%. Oh, I drew it terrible. That's what I get for making fun of his accent. 75% would fall within those 2 values. And then he said the maximum that it goes up to is 89% within the 3 standard. That's an S. Sorry, that's an S. It looks like a 5, but it's really an S. Don't make fun of my S. Three S. I can't do the S either. Yeah, so that's the difference. He skips, and then he starts the 2. And the percentages also. Remember, empirical, it was 68, 95, 99.7. Chebyshev's is only 75 and 89%. And it starts at 2 and then 3. Right. So let's do the problem in your book. We shall do the last one on this page. It is number 43. Oh, yeah, I went too fast. 43. The age I will be in 20 years. All right. So let's do 23. All right, so it says, look what it says. It says Chebyshev. Chebyshev. You're going to use Chebyshev. Based on the data set 1, body data in Appendix B, blood platelet counts of women have a bell-shaped distribution with a mean of 255.1. All right, so we know our mean. There it is, 255.1. I'm going to put that for my mean. Here's my mean. And a standard deviation of 65.4. Was it 65? Yeah, 65.4. Okay, well, let's go back to my picture. My picture. Right, there's my mean. There's my mean. Boop. Right, so he says to skip it, but I'm gonna just go ahead and calculate it. Remember, you're gonna go. When you go right, you continue to add 65.4. That's a point, right? So I'm going to add 255.1 plus 65.4, right? But he said skip it. Don't put it on there, right? So now we add another 65.4. And that one I do record. That is 385.9, and then I'm going to add another 65.4, and that'll give me the last one with 451.3. So if you go back to the previous problem, I had 320, but he doesn't believe it on it. So he said, nah, get rid of it. I did it. Okay, now when you go left, you got to subtract. So 255.1, I'm going to subtract 65.4, but it's supposed to be 189.7, but he says skip it, delete it, right? And then I'm going to subtract another 65.4, and that one I'm going to record it. And subtract another 65.4, you get 58.9. So there are the readings for the Chebyshev. I just skipped. I don't fill in these. I skip it. I mean, you can put it down and just block it off, but he doesn't believe it. Okay, so now we can answer the questions. So I believe there's two of them. There's part A and part B. Part A says, what is the percentage? What is the percentage? What is the percentage of that are within, sorry, that are within or between, between 97 point, am I doing the right one? No. That are within 3 standard deviations. Sorry, that are within 3 standard deviations. I was reading the wrong one. Within 3 standard deviations. All right, so 3 standard deviations. I'm looking for the 3s. There they are. I'm going to write them down. 58.9 and
Can I get you anything right now? Let me know if you need anything, okay?
okay, now part B. Let's look at part B. Part B says, what does part B say? What are the minimum and maximum platelet counts that are within? Oh, I already wrote it down. The first one, sorry. What's the percentage? What is the percentage? Oh, I messed up. Okay. So that was part, shoot. So 58.9 and 451.3 answers part B. Sorry. They wanted the percentage. So where does the 3% fall? They want the percentage. See, I didn't read the question right. Yeah, you got to learn how to read. Very important. What is the percentage that are within 3? All right, follow the 3s. It goes 89%. Duh, 89%. Duh. And then part B says, what are the values? There they are. Okay, and I think we're done. So on Thursday, we're going to do 3-3. We're going to do measures of relative standing. That doesn't mean that you're going to measure your small d, all right? That's very hobbit size. No, that's something else. Well, we are going to measure weights and heights. We'll cover z-scores. We'll cover percentiles, quartiles, and then we'll do box plots. All right, and we're done. Have a good day. Bye, guys.